0. Here, 3 times plus 2, you have plus 6. Plus 2n equals to 0. By collecting like terms, then you have 2n equals to minus 6. Then we divide both sides by 2. You divide both sides by 2, you have minus 6 divided by 2. Then at the end, you have n equals to minus 3. So the oxidation number of nitrogen in this nitride is minus 3. Therefore, the answer to question number 2 is A. Question number 3. Nitrogen combines reversibly with hydrogen under A. Catalyst, B. High voltage electric spark, C. The presence of traces of nitrogen 2 oxide, D. In vacuum. It is the best answer that suits this question is in the presence of catalyst, because that is what is known as the Haber process, where you have your nitrogen gas plus 3 moles of hydrogen gas in a reversible reaction, and in the catalyst here is ion filings to give ammonia gas. So it is in the presence of the catalyst. That is why the answer to question number 3 is A, catalyst. Question number 4. Hydride of nitrogen, which is capable of turning red litmus blue, makes the nitrogen to have the oxidation number of A plus 2, B minus 2, C plus 3, D minus 3. Hydride of nitrogen. The only hydride, the commonest hydride of nitrogen that is generally known is ammonia. Here, hydrogen has plus 1, N plus 3 atoms of hydrogen into the plus 1 state is equal to 0. So N becomes plus 3 equals to 0. So collect like terms, you have 0 minus 3. So your N equals to minus 3. So the oxidation number of nitrogen in the hydride, which is ammonia, is minus 3. Therefore, the answer to question number 4 is D, minus 3. Which of the following is an alkaline gas? An alkaline gas is a gas that will turn red litmus paper blue. A. Laughing gas. B. Nitrogen 2 oxide. C. Nitrogen 4 oxide. D. Ammonia gas. Laughing gas is N2O. That's nitrogen 1 oxide. This is not an alkaline gas. Neither is it an acidic gas. So, option A is wrong. B. Nitrogen 2 oxide. Nitrogen 2 oxide 2 is not an alkaline gas. Nitrogen 4 oxide. Nitrogen 4 oxide is not an alkaline gas, but it is an acidic gas. Then the last option, D, ammonia gas. Ammonia gas is an alkaline gas because it is basic. So it is the only gas that has the tendency to turn red litmus paper blue. So the answer to question number 5 is D, which is ammonia gas. Sulfur. Elements in group 5A include oxygen and sulfur. Therefore, sulfur is placed in group 5A. Sulfur is a non-metal. They are electron acceptors and are oxidizing in nature. When I say electron acceptor, I mean they have the tendency to accept electrons, and that is what accounts for them being non-metals. Electron structure of sulfur. The electron configuration of sulfur is 1s2, 2s2, 2p6, 3s2, 3p4, which is 16, because of the fact that sulfur has the atomic number of 16. Sulfur exhibits allotropy. What is allotropy? An allotropy is the ability of an element to exist in more than one form in the same physical states. The allotropes of sulfur. We have several allotropes of sulfur, which are rhombic sulfur, monoclinic sulfur, amorphous sulfur, and plastic sulfur. Hydrogen sulfide. Hydrogen sulfide is a compound of sulfur. It is found in volcanic gases, sulfur springs, etc. Preparation. How can hydrogen sulfide be prepared? It is prepared by action of dilute acid on metallic sulfide. What kind of metallic sulfide are we talking about here? Iron sulfide plus hydrochloric acid gives hydrogen sulfide, which is the gas, plus iron 2 chloride aqueous. So here, the reaction of iron 2 sulfide, which is the metallic sulfide, with an hydrochloric acid give hydrogen sulfide, which is a compound of interest here. Physical properties. It is a colorless gas with a repulsive, rotting egg smell. It is very poisonous. It is about 1.18 times denser than air. It is moderately soluble in water. It burns with a pale blue flame. Hydrogen sulfide, chemical properties. It reacts with sodium hydroxide when in limited and excess supply to give normal salts and acid salt respectively. And this is the reaction to justify that. Sodium, 2 moles of sodium hydroxide plus hydrogen sulfide and sodium hydroxide plus hydrogen sulfide. In this case, you have the formation of a normal salt plus 2 waters. Here, you have the formation of acid salt plus water. This is a normal salt. This is an acid salt. Here in limited supply, here in excess supply. You can see that the concentration varies. In the limited supply of this, you have a normal salt being formed, sodium sulfide. But in the excess supply of hydrogen sulfide, you have an acidic salt being formed, which is sodium hydrogen sulfide. 2. It reacts with oxygen in limited and excess supply to give water and sulfur and water and sulfur 4 oxide respectively. Based on the reaction with oxygen in the limited and excess supply, hydrogen sulfide plus oxygen, this is excess supply, excess. Hydrogen sulfide plus oxygen in limited supply. In excess supply, it gives water and sulfur 4 oxide. In limited supply, it gives water and sulfur. So hydrogen sulfide gives water and sulfur oxide in excess supply of air, which is oxygen. In the limited supply of oxygen, it gives water and sulfur. So that is the difference between them. Reaction with chlorine to give hydrogen chloride gas and sulfur. Hydrogen sulfide reacts with chlorine to give hydrogen chloride gas plus sulfur. Is a gas plus sulfur solid. That's the reaction of hydrogen sulfide with chlorine. It gives hydrogen chloride gas and sulfur. Reaction with sulfur 4 oxide to give water and sulfur. And this is done 2 moles of hydrogen sulfide gas reacting with